Today I am going to start the first chapter of your class 11th chemistry, that is some basic concepts of chemistry. The name of the chapter itself is self-explanatory. In this chapter we are going to study some of the basic concepts that are related to the study of chemistry. Unless your basics of chemistry is not strong enough, you will find class 11th and class 12th chemistry very difficult. First, you must try to understand the concepts clearly, and if you study the first few chapters of your class 11th chemistry very well, then no doubt that in class 11th and 12th the study of chemistry will become more interesting and exciting. Here I will teach all the basic concepts related to the study of chemistry clearly, so that the foundation of chemistry becomes strong, on which you can build a tall structure of chemistry. Without wasting much of our time, we will directly get into the chapter. Before that, you must sit with a pen, notebook and a calculator. Sit in a calm place where there is no disturbance and try to listen carefully. Okay? The study of chemistry starts with the concept of matter, because chemistry is the branch of science that deals with the study of matter, their composition and properties. I think the word matter have been introduced to you when you were in class 4th or 5th, right? You are very much familiar with this word matter, and I think when you were in 4th or 5th, the first question in your science notebook was, what is matter? So I don't think there will be students in class 11th studying science without knowing the definition of matter. So what is matter? Anything that has mass and can occupy space are called matter. Anything that has mass and can occupy space are called matters. Can you give few examples for matter? Is it difficult to give few examples for matter? Definitely no, because everything that we see in and around us are matter. Pen, book, calculator, table, duster, chalk piece, board, plants, animals, you, me, everything that we see in and around us are matter. For example, if I take this duster has got some mass and it occupies space, therefore this is a matter. This chalk piece, it has got mass and it occupies some space, therefore it is a matter. So like this, everything that we see in and around us are matter. If everything that we see in and around us are matter, is there anything which is not a matter? Yes, there is. Radiations are not matter. Light, heat radiations, x-rays, gamma rays, all these are not matter. They occupy space but they don't have any mass, therefore they are not matters. For matters you can give many examples, but for non-matters it is very difficult to give example, but some of the examples are radiations. Okay, next, matter is classified into different types based on the physical nature of the matter and chemical nature of the matter. Based on the physical nature of the matter is classified into three types, that is solid, liquid and gases. Apart from these three states, there are two more states of matter, that is Bose-Einstein condensed state of matter and plasma state. You can see the matter in Bose-Einstein condensed state only at very low temperature, and matter exists in plasma state at very high temperature, that is inside stars. Okay, so based on the physical nature of matter, there are 5 states of matter. One is solid, liquid, gases, Bose-Einstein condensed state and plasma state. Anyhow, in this unit we are going to discuss about the classification of matter based on the chemical nature, that is the chemical classification of matter. So depending on the chemical nature of matter, matter is broadly classified into two types: mixtures and pure substances. First, let us take mixture. What is a mixture? The name itself indicates a mixture is formed when two or more substances are mixed in any proportion by mass. When two or more substances are mixed in any proportion by mass, a mixture is formed. For example, you can take a mixture of sugar and salt. You can take sugar and salt and mix them. Here, the proportion in which you will mix is not important. You can take 5 gram of sugar and mix it with 8 gram of salt, or you can take 3 gram of salt and mix it with 6 gram of sugar. In any proportion by mass you can mix them. So sugar and salt mixture. Air is mainly a mixture of 80% nitrogen and 20% oxygen. So air is a mixture. Sugar solution is a mixture of sugar and water. Salt solution is a mixture of salt and water, etc. These are the few examples for mixture. Mixtures are further classified into two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture, it is a mixture of two or more substances having uniform composition throughout. What do you mean by uniform composition throughout? Let us take an example, then you will understand clearly. If I take a sugar solution, that is sugar dissolved in water. Now, you take a drop of this solution from this point and you taste it, and another drop from somewhere here and you taste it, and now you tell me whether the taste is different. No, right? The taste is same. Why the taste is same? Is because sugar is uniformly distributed in water. That is, the composition is uniform throughout. That is why the taste is same. Such mixtures are called as homogeneous mixture. The mixture of two or more substances having uniform composition throughout. One more example, let us take air. Air is a mixture of mainly 80% nitrogen and 20% oxygen. Wherever you go, the air contains 80% nitrogen and 20% oxygen. Nitrogen and oxygen is uniformly distributed throughout in the air. So such mixtures are called as homogeneous mixtures. Okay, next, heterogeneous mixtures. Mixtures of two or more substances which does not have an uniform composition throughout. Mixture of two or more substances which does not have uniform composition throughout are called heterogeneous mixtures. For example, if you take solid sugar and solid salt, if you take a mixture of sugar and salt and you mix them, whichever way you mix, however you mix, and after mixing, if you taste a part of it from this point and if you taste a part of it from this point, the taste will not be same. The taste will be different because the distribution is not uniform. The composition is not uniform throughout. Then such mixtures are called as heterogeneous mixtures. So what are heterogeneous mixtures? Mixtures of two or more substances which does not have uniform composition throughout. Okay, next, pure substances. It is a form of matter which is made up of only one type of particles. It's a form of matter which is made up of only one type of particles. For example, if you take copper, copper is a pure substance because it is made up of only copper atoms. Similarly, if you take zinc, Zinc is a pure substance because it is made up of only zinc atoms. If you take oxygen, oxygen is made up of only O2 molecules. If you take water, water is made up of only H2O molecules. If you take sodium chloride, it is made up of only sodium chloride particles. So when I say particles, it can be either atoms or molecules. So pure substance is a form of matter which is made up of only one kind of particles. Is it clear? Next, pure substance is further classified into two types: elements and compounds. First, let us take elements. Elements is a pure substance which is made up of only one kind of atoms. Elements are the pure substances which is made up of only one kind of atoms. There are nearly 118 elements. You can see all of them in the periodic table. Starts from hydrogen, then helium, then beryllium, boron. This is how you find all the elements in the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. All these are called as what? They are all called as elements. Hydrogen element is made up of only hydrogen atoms. Helium element is made up of only helium atoms. Sodium element is made up of only sodium atoms. So elements are the pure substances which are made up of only one kind of atoms. So there are nearly 118 elements, and these 118 elements are classified into three types like metals, non-metals and metalloids. Next, compounds. A compound is formed when two or more elements combine in a fixed ratio by mass. A compound is formed when two or more elements combine in a fixed ratio by mass. For example, if I take water, you collect water from any source. It may be a tap water or pond water or well water or rain water. It always contains hydrogen and oxygen combined in the ratio 1:8. Only when hydrogen and oxygen combine in the ratio 1:8, water will be formed. So water is a compound. A compound is formed when two or more elements combine in a fixed ratio by mass. Similarly, if you take carbon dioxide, carbon and oxygen combines in the ratio 3:8. So carbon dioxide collected from any source or prepared from any method will always contain carbon and oxygen combined in the ratio 3:8 by mass. Okay, there are millions of compounds. So all these compounds are formed when these 118 elements, when they combine with each other in a fixed ratio by mass. And these compounds are further classified into two types like organic compounds and inorganic compounds. So compounds of carbon are called organic compounds and the remaining compounds are called as inorganic compounds. Okay, these are the few definitions of matter, mixture, homogeneous mixture, heterogeneous mixture, pure substance, elements and compounds. On the examination point of view, you may get a question like to write the difference between mixture and compounds. When you are asked to write the difference between mixture and compounds, you must make two columns. On one side you will write mixture, the other side compounds. The first difference, you can write the definition. A mixture is formed when two or more substance is mixed in any ratio by mass. Compound is formed when two or more elements combine in a fixed ratio by mass. What are mixtures? Mixture is formed when two or more substances are mixed in any ratio by mass. Compound is formed when two or more elements combine in a fixed ratio by mass. Second difference, the mixture, for example, if you take sugar and salt mixture, the mixture that is formed will have all the properties of the substances from which it is formed. Now sugar will have its own property, salt will have its own property. You mix sugar and salt, you get a mixture. That mixture will have all the properties of sugar as well as the properties of salt. So mixture will have all the properties of the substances from which they are formed. But in case of compounds, the compound will not have any of the properties of the constituent particles from which they are formed. For example, if you take water, water is formed when hydrogen combines with oxygen. The properties of hydrogen. Hydrogen is an highly combustible gas. Oxygen, as you know, it is a supporter of combustion. But when hydrogen and oxygen combines to form water, water will not have the properties of hydrogen or oxygen. It will have some new properties. Water is neither a combustible gas or it is not a supporter of combustion, but water is used to put off the fire, right? So compound will not have the properties of the constituent elements from which it is formed, but mixture will have all the properties of the constituent substances from which it is formed. So this is how you can write the difference between mixture and compounds. Next, after this, usually in chemistry we will be talking about the physical properties of a substance and chemical properties of a substance. You might have come across these terms, physical properties and chemical properties, when you were in class 10th, right? Next, physical properties and chemical properties. So what are physical properties? So the properties of the substances which can be measured and observed without changing the composition of the substance. What are physical properties? The properties of the substances which can be measured and observed without changing the composition of the substance. What does it mean? If I ask you to tell some of the physical properties of this chalk piece, what you will do? Without changing the composition of the chalk piece, you can tell its color. If it has some smell, odor, you can tell its odor. You can, without changing the composition of this chalk piece, you can tell its mass, density, even melting point, right? So color, odor, density, mass, melting point, boiling point, etc. are all physical properties of the substance. You can speak about its color, density, mass without changing the composition of the chalk piece, without doing anything to this chalk piece, right? But if I ask you whether this chalk piece is acidic in nature or basic in nature, then you may have to treat it with some base so that it will give a new compound, that is salt and water, that is its composition is changed. So such properties are called chemical properties, the properties of the substances which can be measured and observed only by changing the composition of the substance. Example, acidic property, basic property, oxidative property, reductive property, all these are chemical properties. So for physical properties, you will not change the composition of the substance, but to study the chemical properties of a substance, you must change the composition of the substance. So is this point clear to you? Okay. In the next class, we will study some of the laws of chemical combination, and this is all for today's class.